Here's my Lab 3 Magnetics lab. All right, what is this lab about? What we're doing is we're observing the changes in a magnetic field by varying the distance of the observation location. We're experimentally determining the magnetic dipole moment, and we're going to compare our experimental results of the magnetic field to a model that we made in GlowScript. The physical principles at play are, well, just the Biot-Savart law for magnetics. And for a summary, in the end, experimentally determined magnetic dipole moment. And we use that in our computational model to determine the B-net. Here are my data and measurements. We were provided an Excel spreadsheet and filled all the boxes out in yellow. Here is the equation that we used to find the magnetic moment of a dipole. And this is equal to the ln of bx. And so to find the magnetic moment of a dipole, we rearrange the Biot-Savart equation and put this to the power of e to get this number. And we found that this number is fairly accurate, as a magnetic moment of about 1 through 3 represents a generally light magnet. In our observations, we found that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction when it is on axis. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Here's my coding. All these arrows represent arrows of the magnetic field at their respective observation locations. The turquoise arrows represent the perpendicular arrows, and the orange arrows represent the on-axis arrows. The purple arrow represents the arrow that is 45 degrees from the magnet. And one of the most important findings in our lab was the comparison of the magnetic field magnitude that we found experimentally and the Bmag that we found in our model. The Bmag that we found experimentally was 5.28 e to the negative 5, and the Bmag we found in our model was 4.6 e to the negative 5, which essentially is saying that we overestimated the Bmag and there was some error in our experiment. Here's some code that I deemed was important. This code is showing the arrow and this arrow is representing the Bmags that we are comparing. And this is the function that we used to more efficiently calculate all the Bmags that are represented by these arrows. Finally, to answer some questions, what if you hadn't oriented your experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? Our X component results would have reflected the Earth's magnetic field and the magnet's magnetic field combined, rather than just the magnet. Second question is, what if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your results to differ? Well, the magnetic field would be stronger, and the magnetic field, more specifically, would be about twice as strong. That's the end of my presentation. Thank you very much.